Chapter 12, Section 3, Exercise 3. At the bottom of page 2, we have a formula from the textbook for projectile motion. In Exercise 3, which is problem number 26 from the textbook, we are to determine the maximum height and range of a projectile fired from a height of 3 feet above the ground with an initial velocity of 900 feet per second at an angle of 45 degrees above the horizontal. Using the formula from the bottom of page 2, we have the following vector-valued function. We can simplify this a little bit. This component function, x of t, is the horizontal component. The second component function, the vertical component, we will call y of t. The maximum height occurs at the moment when the projectile has stopped rising. That occurs when the vertical component has derivative 0. So we will solve y prime of t equals 0. And y prime of t is 450 square root of 2 minus 32t. Set that equal to 0. T equals 450 square root of 2 divided by 32, or about 19.89 seconds. But since we have computations that depend on this solution, we will use the exact form of the solution, not the decimal approximation. So the maximum height, y of this solution, I used a TI-89 to do this arithmetic quickly. 6,331 1/8 feet, which is about 1.2 miles. So this projectile reaches a height of about 1 1/5 miles in the air. To determine the range of the projectile, we mean that we are trying to find the horizontal distance that it traveled. So first we're going to find when the projectile hits the ground. When it hits the ground, it is no longer traveling, and its distance is complete. So we will solve y of t equals 0 to find when the projectile is height 0, in other words when it hits the ground. So you're going to use a quadratic formula, and I know you can do that, so I'll go straight to the solutions. There is a positive solution and there is a negative solution. Since t is a measurement of time, we will take only the positive solution. This is a TI-89's version of the quadratic formula, and we get about 39.78 seconds. So the horizontal range, or distance traveled, is x of this number here, but I'm going to be just a tiny bit sloppy and use a decimal approximation. And we get approximately 25,315.5 feet, or about 4.8 miles. The moral of the story: don't play with guns.